Okay, boys and girls, this is our Chapter 7 review. I wasn't really going to make this video because I don't think this is the hardest one that we're going to have. But since a couple of people were absent yesterday, I'm going to go ahead and do it. It's just probably not going to be the best one that we've ever done. But we'll give it a go. So here we go. The Chapter 7 review. Alright, so as I told you yesterday, the format is like the last one. There are 10 true-false questions. There are 10 multiple-choice questions. There are 5 free response questions, and those have multiple parts. Now, I'm not going to separate necessarily by section. I'll just talk about some of the concepts and then tell you kind of how they apply and where. Probably the most important thing is that you are familiar with the formulas that we learned in this chapter. Knowing that mu sub p hat is equal to p, and that sigma sub p hat is equal to the square root of p times 1 minus p divided by the sample size. And knowing that mu sub x bar is equal to mu, and that sigma sub x bar is equal to sigma divided by the square root of n. And the reason knowing these formulas is so important is because it comes up in every section. Let's start with the free response, how you might have to do that. In the free response section, you would use either set depending on if we're dealing with a proportion or a mean. You would have to find, oh, that was a neat trick. There we go. You would have to find the mean and the standard deviation so that you could find the z-score. And the reason you do that is so that you can calculate some probability. So really, on most of the free response questions, it's like this is part A, this is part B, this is part C. And so you're going to have to do that process a couple different times. Something like that. Find the probability that x bar is less than some given number. Okay? So that's why it's imperative that you know the formulas. Another reason it is imperative that you know the formulas is that you can comment to things like this. What happens to standard deviation as sample size increases? Well, by knowing the formula, you can see that these are inversely proportional. That is, as this guy goes up, this guy goes down. Same thing if you were looking at sigma sub p hat. So that's another reason why it's important to know the formulas. Another couple of formulas that you have to know is knowing when you can use normal. Because this is asked in multiple sections. It'll say demonstrate that you can use the normal, and that's when you show that np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. So a couple more formulas for you to know and know how to use and what they're used for. The worksheets that we did yesterday, where we did all the stuff with the z-scores, was just exercises to help you answer the kind of questions that you're going to answer on the free response, where again you find the mean, the standard, the deviation, and some probability. So that's why we did so much time on those. What we didn't do as much of that you have to do though is find the new mean, which actually doesn't change, right? But the new standard deviation does. So you're going to have to do that, which is why we did so many on the worksheet. Another important thing to know is when the central limit theorem applies. When n is greater than or equal to 30, means you can use normal. No matter what shape distribution you're drawing from. Oh no, there goes the whole thing. So if my population distribution looks like this, and I'm only sampling 5, then that distribution is going to resemble that, and so normal would be inappropriate. But if my population distribution looks like that, and instead I sample 50, then that is going to look like that. So it's okay to use the normal. So that's going to help you for a couple of different type of questions, maybe in the true false, maybe in the multiple choice. Knowing when it's appropriate, what it allows you to do, and then also knowing what shapes will look like. So for instance, if it tells you, I'm trying to make it go forward, but it doesn't want to. So if it tells you that your distribution is left-tailed, that kind of looks left-tailed, all right, then you would know that samples drawn from this would resemble left-tailed until you get around that 30 point. And then some of the exercises we looked at, you saw how quickly it actually normalized. It did around 20 or 25, but 30 is the magic number for this test, central limit theorem. I think that really hits just about all the problems that you have to do. This is not the most difficult test that we'll take. If you have any questions, feel free to come by in the morning. Our test is the second period of the day, and I'm usually here around 6:30. So I'll be in my office till then. Good luck. Do those review problems because I might take them up. You never know.